Welcome back to another episode of Calculus. I have to reshoot this one after the original time I did this because, oh god, it didn't load. So now we're going to talk about E. So we know that this equation by heart by now. Right? Your new budget equals your original budget times 1 plus your rate divided by the number of times you're compounding it, raised to the power of your number of times you're compounding it times your time in years. Okay. This is for compound interest. So let's go ahead and look at when your initial budget is 1 plus your rate is 100% or just 1, right? And your time is always over 1 year, right? So what would it be at after one time compounding it? We get 2. What if you compound it twice? Yeah, 2.25. What if I compound it 100 times? Well, if you pull out your calculator, your handy dandy calculator, you get right around 2.705. What if I calculate it 1,000,000 times, or 10 to the 6th? Right? What would this give me? We'll plug it into your calculator. I don't think I did mine right, so I'm gonna plug it in again. Well, you get the point. It's like going to be somewhere like 2.71828. Okay? So, what if n approaches infinity just as dx approaches 0, right? N is approaching infinity here. 1 plus 1 on n to the n, okay? Well, it's going to be somewhere around here, right? Because 10 to the 6th is pretty big. But maybe not exactly. So let's go ahead and think about, you can't get an exact value for this. So let's just make it a constant e. Okay? Now I'm going to do a little rewriting of e. What if I say dx is 1 over n and 1 over dx is equal to n? You'll see why I call it dx. Well then, what would dx be approaching if it's 1 over n? Well, n's approaching infinity, so that means dx is approaching 1 over infinity, which is approaching 0, right? So dx is basically just approaching 0. Let's make the substitution. So 1 plus dx is 1 over n, so dx. And then 1 over dx is just n, so 1 over dx up there. Now you'll see why I did this in a little bit. When we're talking about the derivative of e to the x. Well, we know the equation is the derivative. It's y of x plus dx minus y of x divided by dx. This will get us somewhere. Well, x plus dx is going to be e to the x plus dx, right? Minus e to the x, dividing that by dx. Off of that, you'll get e to the x e to the dx minus e to the x on dx. And here we get e to the x, factoring it, e to the x times e to the dx minus 1 over dx. From this, well, we know what e is. It's 1 plus dx, because dx is going to 0, right? 1 over to the power of 1 over dx. So we get then 1 plus dx to the power, well, let me write it down a little lower, 1 plus dx to the power of 1 over dx, all raised to the power of dx, minus 1, all over dx. This is all being multiplied by e to the x. Okay, you can multiply this down. The exponent becomes 1, so we get 1 plus dx to the first power, it's just 1 plus dx, minus 1 over dx. Well, we don't need, these cancel out. This right here becomes 1, and look at that, we get e to the x. There. It might be useful if I turn on another light. There we go. So, now, we have the derivative of e to the x is e to the x. What about something like 2 to the x? What's the derivative of that? Well, we have to talk about logarithms. What about them? So, we know that if 2 to the x, let's say it's going to be equal to 3, 3, 5, 5, 4, 4, 3, 2. Or in other words, 33,554,432. What's x? What's x going to be equal to? You know it for like 2 to the x equals 32. That's pretty easy. X is equal to 5. It's 2 times 2 times 2 times 2 times 2 is 32. But in this case, what would it be equal to? And that is what the logarithm is for. So we say the log base 2 of 2 to the x is just x. It cancels it out. Log base 3 of 3 to the x is just x. Log of a base 4 of 4 to the x is equal to x. That's why we call these bases. Because if I'm doing a logarithm of the same base, you'll get out x. Log base n, that's 2, a base n of n to the x is just x. Okay? I think that light is actually doing less good than it is improving. So now, this is what we get out of all of it. So, how would we do this? Well, take log base 2 of both sides. You get log base 2 of 2 to the x is equal to log base 2 of 33,554,432. And then you get x equals, because log base 2 of 2 to the x is just x, plug this into your calculator. What you do is you hit the log button, Then you type in your number. And then you divide by the log of whatever your base is on the logarithm. This gets out the answer 25. So x is 25. If you actually plug this back into your calculator, 2 to the 25th, it is this right here. So that's why we use logarithms. So what? Well, there's a very special logarithm. ln. It cancels out e to the x. Okay? And here's another fact you should know. That e to the ln of some of x is just x. This is because take the natural log of both sides. Natural log of e to the natural log of x. Just the exponent. Natural log of x. Take the natural log of that side. It's natural log of x. That's why. So, yeah, it's pretty obvious that e to the natural log of x is x. Basically meaning e to the natural log of 2 is 2. So now, let's talk a bit more about that. So we're doing derivative of 2 to the x. Same thing as the derivative of, as we've seen, e to the natural log of 2 to the x. Multiply that down. Derivative of e to the x natural log of 2. I'm going to write it like that from now on. Which then gives us e to the natural log of 2 times x plus dx minus e to the natural log of 2 times x divided by dx. This gives us, when factored, e to the natural log of 2 x times the quantity of e to the natural log of 2 dx minus 1 over dx. Now, I'm going to use a little fact that I won't prove, but e to the a is the same thing as 1 plus a on n, or rather a times dx to the 1 over dx. Okay? You can just multiply the dx on the inside like that. This has to do with the natural log of both sides and stuff, but we're not going to go into that yet. So now, from this, we can get e to the natural log of 2x. That's just going to be 2 to the x. Then in here, we have 1 plus natural log of 2 dx to the power of 1 over dx, right? To the power of dx, all of that to the power of dx, minus 1 over dx. This gives you 2 to the x, times, well, you can see what we're getting here. It's going to be the natural log of 2 times dx on dx. You see that? Because the 1's cancel, dx, that's power of 1. 1's cancel. Then you get this, which is then going to be natural log of 2 times 2 to the x. Turns out that any n to the x, their derivative is the natural log of n times n to the x. Okay? So now some problem questions will be 1. what is the derivative of e to the x times x squared? Number 2, what is the derivative of e to the x on x? And number 3, what is the derivative in respect to x of 2 to the x times 3 to the x? Now, remember, the hint is the product rule. The derivative of f of x times g of x, or rather, derivative of left times right is left d right, right plus right d left. Okay? That's enough for today.